Okay. Bismillah ar-Rahman ar-Rahim. We'll continue. Doing this one. Okay. Now we'll finish. That was the last problem we did. Now we'll continue doing these all the exam questions. Okay. I think the idea is clear, but now just practicing more examples. Okay. Cosine of 5x squared. So we'll start with what? Cosine x. What you want? You want the coefficient of x to the power 4. Okay. So cosine x. Cosine x is what? Summation n equals 0 to infinity minus 1 to the power n x to the power 2n over 2n factorial. Okay. 5x squared. So I replace x, 5x squared. That will be what? Summation n equals 0 to infinity minus 1 to the power n. Then I have 5x squared all to the power 2n over 2n factorial. And that is 0 to infinity minus 1 to the power n. This is what? 5 to the power 2n x to the power 4n over 2n factorial. Notice one thing. When I will get x to the power 4, n equal 1, give me x to the power 4 for these things. So I'll check n equal 1. At n equal 1, what will be the coefficient? It will be minus 1 to the power 1, 5 to the power 2 times 1, x to the power 4 over 2 factorial. So that'll give me what? Minus 25 over 2 x to the power. And that's my coefficient. Okay. Tan inverse x cubed. What is tan inverse? If you remember, that will be n equals 0 to infinity minus 1 to the power n x to the power 2n plus 1 over 2n plus 1 without factorial. Yeah, just to remind you, this is the one. Tan inverse. I'm looking at tan inverse. It's minus 1 to the power n x to the power 2n plus 1 over 2n plus 1. Okay. Okay. What I want tan inverse. Instead of x, I have x cubed. That will be summation n equals 0 to infinity minus 1 to the power n x cubed all to the power 2n plus 1 over 2n plus 1. That will be summation minus 1 to the power n over 2n plus 1. Okay. And you have what? X to the power 6n plus 3. Now we need the integral of this. Integral of tan inverse x cubed dx. Okay. So let's integrate this. I'm getting what? Minus 1 to the power n over 2n plus 1 over 2n plus 1 times what? X to the power, I add 1 and then divide by that. So this will be my answer, which is exactly this one. That's it. Use the rational term series, the first 3 non-zero terms of this function, sine x, but at what? At y over x. I need to find it then. F prime will be cosine, F double prime minus sine. This is what I need. I don't think I need the third one. I need the first 3 non-zero terms. Yeah. I think it will be more than enough. Let me do it. Okay. So I have f at y over 6. That will be what? Half f prime at pi over 6 square root over 2 f double prime at pi over 6 minus half. Yeah, I don't need anything more, but just for completeness. Okay, so my function will be what? F at pi over 6 plus f prime pi over 6 times x minus pi over 6 plus f double prime pi over 6 plus something. F pi over 6 is what, half? F prime square root 3 over 2. F double prime minus half. And the first 3 non-zero terms, which is these 3 terms. 1, 2, 3. Yeah. No, don't forget. Here I have the factorial. So this is will be not 2. The formula I have the factorial, okay? So this is the answer. Not 2. This one. Need to rewrite this. So this is summation. By 2n minus 1 over 3 2n minus 1 2n factorial. This will be what? Since I have 2n factorial, so I think about cosine. So let me make it in the same format. The numbers I can throw away. This is pi to the power 2n over 3 to the power 2n times 1 over 2n factorial. What's the remaining? I have bias minus 1 over 3s minus 1. This is just a number. I can throw it away. I can make it in the, because that will be 3 over pi, this summation. Make it, this is pi over 3, all to the power 2n over 2n factorial. Exactly, now it is cosine. Okay, now I have, this is 3 over pi times cosine pi over 3. And that will be cosine pi over 3 is half, so 3 over 2 pi. And that will be my answer. Okay, I have e to the power x, and the same thing are going back and forth, x to the power n or n factorial, but everything depends on you remember the formulas. 0 to infinity, that will be minus x to the power 4 to the power n over n factorial, which is equal to what? Summation n equals 0 to infinity minus 1 to the power n over n factorial x to the power 4n. Now multiply by x squared, that will be 4n plus 2. Now integrate from 0 to 1. Previous, when we do integration, we need this plus c, huh? Now this one, I don't need plus c, so that will be what? Summation n equals 0 to infinity. I need to integrate minus 1 to the power n over n factorial x to the power 4n plus 3 over 4n plus 3 over 4n plus 3 from where to where? From 0 to 1. 1 will not make a change, and 0 actually will not make a change. 1 just substitute. So you have 4n plus 3. 0 will make it 0. What is my answer? Let x equal this. He wants the 17 derivative of this function. What shall I do? Okay. I know that the series usually make it like this. It is the n derivative at 0 over n factorial x to the power n. Okay. So let me write this, and then I will find the coefficient. Then I will find n. Okay. So let me write this first. Cosine x is what? Summation n equals 0 to infinity minus 1 to the power n. Then I have what? Minus 1 to the power n x to the power 2n over 2n factorial. Now cosine x square, that gives me summation. Let me do it directly. Minus 1 to the power n x to the power 4n x to the power 4n over 2n factorial. X cosine x square, that will be summation n equals 0 to infinity minus 1 to the power n x to the power 4n plus 1 over 2n factorial. Okay. So what will be this? F of 17 at 0. Or let me do it the other way. If I open this and I want the 17, the power 17, x to the power 17, something, something, plus x to the power 17. What that would be? I have n equal 4. So at n equal 4, that gives me x to the power 17. Yeah, very clear from here. So n equal 4, so I have minus 1 to the power 4 over 2 times 4, 8 factorial. That will be coefficient of x to the power 17. And the coefficient of x to the power 17 from this one, this, so I have minus 1 to the power 4 over 8 factorial is the same as the 17th derivative at 0 over 17 factorial. Because also at n equals 17, this will be the same coefficient. So now solve for f17 at 0. That will be what? Minus 1 to the power 4 is 1. That will be 17 factorial over 8 factorial, which is this. Which is clear. Now this one, I want to rewrite it. Okay, I have here pi over 2. Let me take it inside. So first, before that, let me do one thing. This is minus 1 to the power n. Let me simplify the things. Pi to the power 2n over 2 to the power 2n. I have 1 over 2n plus 1 factorial. Don't forget the pi over 2. I have this 2n plus 1. So I want everything in terms of 2 plus 1. Now I'm going towards sign. Huh? So I have n equals 0 to infinity, minus 1 to the power n, pi to the power 2n plus 1, 2 to the power 2n plus 1, and here I have 2n plus 1 factorial. In other words, I can rewrite it, minus 1 to the power n, pi over 2 all to the power 2n plus 1 over 2n plus 1 factorial, which is directly, will be sine pi over 2, which is 1. So let's do that. By using the binomial series, the coefficient of x to the power 4 in this power series. What is this? I want square root 4 plus x squared, which is 4 plus x squared to the power half. It's not ready. I want the coefficient, I want this to be 1. So what I will do, I can take 4 common factor. Take 4 common factor. We have what? 1 plus x squared over 4 all to the power half. That will be 2. 1 plus x squared over 4 to the power half. Now it's almost ready. Yeah. Now I use the binomial series. That will be 2. Don't forget the 2. I have what here? 1 plus kx. This is my x. K is half. This is k. So I have half x squared over 4. I want what? The coefficient of what? X to the power 4. Okay. Plus, this is I have. Yeah. Okay. Now I have what? K, which is half. K minus 1, half minus 1 over 2 factorial times x squared. X squared over 4 all square plus something. This what will give me coefficient of x to the power 4. Because if you look at this one, it will be what? Half minus half over 2 factorial. I have what? X to the power 4 over 4 square. So that will go to where? It's minus 1 over 2 times 2 times 2, 2 to the power 3. Here 4 square is what? Is 2 square square. That will be 2 to the power 4. So 2 to the power 7, x to the power 4. Is this my coefficient? No, because I have 2. So the coefficient of x to the power 4 is 2 minus 1 over 2 to the power 7. And that minus 1 over 2 to the power 6. What is will be the answer? Which is fine. Yeah. The Taylor polynomial of order 3 for this function. This is my function, order 3, just I need up to x cubed. Okay. So f prime will be 1 over 2 plus x, which is 2 plus x to the power minus 1. See it easily. F double prime, that will be what? Minus 2 plus x to the power minus 1. That will give me x, order 2. No, I want order 3. If triple prime minus, no, plus 2, 2 plus x to the power minus 3. I want it at what? At c equal minus 1. So f of minus 1 will be what? 0 here. 2 minus 1 is 0. F prime at minus 1. Yeah, that will be 1. Yeah, that will be 1. F double prime at minus 1. That will be minus 1. Okay. Yeah, 2 minus 1, 1. Okay. If third derivative at minus 1, I have what? 2. Okay. So what will be the function now? F of x will be f of minus 1 plus f prime at minus 1 times x minus minus 1 plus f double prime at minus 1. This is x plus 1. So this is x plus 1 square plus the third. I need the Taylor polynomial for the 3, huh? So I need P3, huh? At x. Okay. The third derivative at minus 1, x plus 1 cubed. That's it. So what is f of minus 1? 0. Gone. F prime is 1. So I have plus x plus 1. F double prime minus. Oh, don't forget. 2 factorial. 3 factorial. Yeah. Don't forget that. The factorial. So this is minus half x plus 1 square. Here I have 2. 3 factorial is 6, so that will be plus 1 over 3 x plus 1 cubed. So this is will be my answer. Exactly. This is 0. So x plus 1 minus half x plus 1 all squared plus 1 over 3 x plus 1 all cubed. Okay. The Maclaurin series generated by this. Yeah, you have only, you give me 4 terms, huh? 4 non-zero terms, okay. Yeah, if you think about f, that is what? 1 minus x to the power 2 over 3. Yeah, so this is my k. It's binomial. Okay, so this is will be what? 1, and this is my x, huh? So 1 plus k with 2 over 3 times minus x plus, I have what? 2 over 3, 2 over 3 minus 1 over 2 factorial minus x squared. I need the third, the next term. I have 2 over 3, 2 over 3 minus 1, 2 over 3 minus 2 over 3 factorial minus x cubed plus the rest. But I need only 4 terms. So that will be 1 minus 2 over 3x. Here I have what? 2 over 3 minus 1. This is minus 1 over 3. So that will be minus 2 over 9 times 2. Okay, x squared. Okay, here I have what? I have, this is minus 2 over 9, 2 over 3 minus 6 over 3 minus 4 over 3. Minus 4 over 3, let me do it in a step. This is 6 minus x cubed plus something, I don't care. Okay, that will be 1 minus 2 over 3x minus 1 over 9 x squared. Here I have what? Minus, minus, minus. That will be minus. Yeah. I have what? 8 over 27 times 6 x cubed plus something. Let me simplify the last one. Yeah, by 2, this is 4, and by 2, this is 3. So I have minus 4 over 81 x cubed plus the rest. So this is my answer. Yeah. Calculation. Yeah. Ternal expansion of this e to the power x over 2 minus 1 at a equal to. Yeah. Okay. So I have what? I need to check the first, the end derivative of this. So what is the first derivative? That will be e. Yeah, let me write the function first. What is the function? It's e to the power 1 over e to the power x over 2. Yeah, I think this is easier now to deal with. Now it will be f prime 1 over e, just a number. This is be e to the power x over 2 times half. Second, just to see the pattern, this is 1 over e times e to the power x over 2 times half times half. So this is derivative of x over 2, then I have half. Third derivative, now it's clear, I think, the pattern. E to the power x over 2 times half times half times another half. Okay, so it will be the end derivative. This is what I want. That will be 1 over e times e to the power x over 2 times half to the power n. Okay, so what will be the Taylor series? F of x will be summation n equals 0 to infinity. The end derivative at a, which is 2 over n factorial, x minus 2 to the power n. What's the n derivative at 2? Let me put it here. The n derivative at 2. That will be 1 over e times e to the power times e times half to the power n, which is what? 2 to the power minus n. Half to the power n or 2 to the power minus. So I have this n equals 0 to infinity, 2 to the power minus n over n factorial x minus 2 to the power n, which is this one. Okay. Next, Maclaurin series of this. I will start with tan inverse. What will be tan inverse? That will be summation n equals 0 to infinity minus 1 to the power n x to the power 2n plus 1 over 2n plus 1. Then find tan inverse x squared. Instead of x, I will write x squared. See what will happen. Minus 1 to the power n over 2n plus 1 times x to the x squared to the power 2n plus 1. Make it clear. That will be summation n equals 0 to infinity minus 1 to the power n over 2n plus 1 x to the power 4n plus 2. Are we done? No. I need x tan inverse of x. So multiply by x. The number will not be changed. I have x to the power 4n plus 3. And that will be my answer. Okay. If the first few terms of the Taylor series about the equivalent is given by this, find this. Okay, so I need to open it up to cubed. Okay, and then take the coefficient. This is the function. This is the function cosine by x. What will be f prime? F prime will be minus sine by x. Don't forget times by. F double prime. That will be minus cosine by x times by square. Third derivative. That will be sine by x times by cube. This is what I need, up to x cubed. Okay. Now, I want it at what? At 1. F of 1 minus 1. F of, cosine by, which is minus 1. F prime at 1, sine by, which is 0. F double prime at 1, that will be what? Cosine by minus 1 times minus, that will be by square. The third derivative at 1, that will be 0. Okay. So it will be f of x. It will be f of 1 plus f prime at 1 times x minus 1 plus f double prime at 1, don't forget, over 2 factorial times x minus 1 square plus a third derivative over 3 factorial x minus 1 cube plus the rest. Okay. F of 1 is minus 1. F prime gone 0. So you have 0 times x minus 1, just to make it clear. This one will be pi square over 2, x minus 1 square. The third one, 0 times x minus 1 cube, plus the rest. Okay. That means what? This is C0. This is C1. This is C2. This is C3. What you want the sum of these C's. That give me what? Pi square over 2 minus 1. This is 0, 0 gone. So this is my answer. Let Px be the sum of the first five non-zero terms, then find P at 1. Okay. So I have cosine x to start with, n equal 0 to infinity, minus 1 to the power n, x to the power 2n, over 2n factorial. I need cosine 2x now. Cosine 2x means I replace x by 2x. So I have minus 1 to the power n, 2x to the power 2n over 2n factorial. That would be what? Minus 1 to the power n, 2 to the power 2n, x to the power 2n over 2n factorial. Okay. Now I multiply 1 plus x by this. Not only 1 plus x. So that means it is cosine 2x plus x cosine 2x. Be careful now. Yeah. So I have the summation of n equals 0 to infinity of minus 1 to the power n, 2 to the power 2n, x to the power 2n over 2n factorial plus x times that, the same series, minus 1 to the power n, 2 to the power 2n. This will be x to the power 2n plus 1 over 2n factorial. Let me open it up. I have what here? I open it up until I have five non-zero terms. I want the first 5 non-zero terms. So at n equals 0, I have what? Minus 1 to the power 0, 1, 2 to the power 0, 1, x to the power 0, 1. So I have 1. At 1, I have what? Minus 2x squared. Let me do it in steps over 2 factorial. At n equal 1. Yeah. 2 to the power. Yeah. No, 2 to the power 2. 2 to the power 2 over 2 factorial. Yeah. At n equal 2, I have what? I have 2 to the power 4 x to the power 4 over what? 2 4 factorial. Yeah. Do I need the 6? Let me write it. I don't need it, but let me write it. That will be minus 2 to the power 2 times 3 to the power 6, x to the power 6 over 6 factorial plus. Now I have the other one. That will be plus. Now at n equals 0. How about 0, 1, minus 1 to the power 0 is 1, 2 to the power 0 is 1. So I have x over 0 factorial, which is 1. Okay. Now, at n equal 1, I have minus 2 to the power 2 x cubed over 2 factorial. Okay. Plus, I need 5 terms, 5 non-zero terms. I don't think I need the rest, but it's okay. Plus 2 to the power. Now n equal 2 to the power 4, x to the power 5 over 4 factorial. Plus the rest. Okay. Now combine them. From here I get 1. From the other one I take x. But I don't, there's nothing to add. Okay. Now this one will be minus 2x squared. So this is the third term. I don't have x squared here. I have x cubed here, which is minus 2x cubed. There's 4 terms. I need 5. Now, this one will be what? Yeah, I have 4 factorial. And that will be 16. Yeah, let me write this. 2 to the power 4 over 4 factorial. 2 to the power 4 over 4 factorial. 2 to the power 4 is 16. 4 factorial is 4 times 3 times 2. Or let me write it this. 4 times 3 times 2. Give me what? Yeah, 16 cancelled 4. That will be 2 over 3. So plus 2 over 3 x to the power 4. I don't need the rest. Okay. Because I need the first 5. This is 1, 2, 3, 4, 5. Now you want me to find p at 1. This is my p, huh? P at x. So what will be p at 1? For the first 5, huh? So my p of x, huh? No, this is not p of x. My p of x will be these terms. 1 plus x minus 2x squared minus 2x squared minus 2x cubed. But these are the 5 terms. 1, 2, 3, 5, non-zero terms. Okay. P at 1. What do you want? 1 plus 1 minus 2 minus 2 plus 2 over 3. That is 2 minus 4 minus 2 plus 2 over 3 minus 4 over 3. And that will be my answer. Yeah, it's just a matter of combination. Okay. For sinusoidal values of x, the Maclaurin series for this is given by this. Yeah, I think this will remind us about 9.9. Okay. So I have what? This is f of x. I can rewrite it as what? 27 over, I can take 3 common factor, if you remember, I have 1 plus 2 over 3x. Yeah, that will be 9. Okay. Now, 1 over 1 minus x, I know it's a summation, x to the power n, where n running from 0 to infinity. Yeah, if you remember, this is what we did in 9.9 actually, but also it is one of the formulas, which is you need to remember. Yeah, similar to this. 1 plus x, if I have minus x, then it will be minus 1 to the power 2, so it's okay. Yeah. So it's 1 plus 1. Let me write this. 1 over 1 plus x. Because I need the plus, actually. So I can use this. Let me go back. So I have 1 over 1 plus x. That I need minus 1 to the power n. Which is I make x minus x. Okay. Now, I have this one, so 1 over 1 plus 2 over 3x. Let me see with 9. That will be 9, the summation. Then I multiply the 9 inside. Summation of what? And instead of x, I'll write 2 over 3x, all to the power n. So that will be 9 times summation n equals 0 to infinity. Multiply the 9 later. Minus 1 to the power n, 2 to the power n, x to the power n, over 3 to the power n. What is 9? 9 is 3 squared. So I'll have this summation n equals 0 to infinity, minus 1 to the power n, 2 to the power n, x to the power n. That will be 3 to the power n minus 2. Since 9 is 3 squared. Don't forget, 9 is 3 squared. What did you write it here? 3 squared. Just to make it clear. So I have this answer. Exactly. Okay. If an is a Taylor series for this function, for this function, what they want an up to 100. Wow. Okay. What is an? An is the n derivative as 3, since c equals 3, as 3 over n factorial. That's an. This is the Taylor expansion. Okay. Now, let me check this function. This is my function. What is its first derivative? First derivative is 3x squared minus 20x. Second derivative. That will be 6x minus 20. Third derivative, that will be 6. Fourth derivative, that will be 0. And the rest, that will be 0 for n greater than or equal to 4. Okay. Now I think things are going clear. F of 3, yeah, I need to do the calculation now. 9 plus 6, yeah, 15 minus 90. 15 minus 90 minus 75. Minus 75. That will be A0. F prime at 3, that will be what? N equals 3. 3 times 9, 27, minus 6, minus 33. 27 minus 60, which is minus 33, and that will be A1. If double prime, no, yeah, this will be A1. Because A1 over 0 factorial, actually, which is 1. Huh? If double prime at 3, that will be what? 18 minus 20, which is 18 minus 20, that will be minus 2 over 2 factorial. No. Minus 2. That will be minus 2. And that is A2. This is A0 times 0 factorial, which is 1. That will not make a difference. A1 times 1 factorial. This is A2 times 2 factorial. Now, the third one, third derivative, R3. That will be 6, and that is a third derivative, A3 times 3 factorial, times, 3 factorial. The fourth one, and so on, it will be 0. That will be 0, which is A4 times 4 factorial. Okay, so let me check now what is A0. A0 will be minus 75. A1, I need to add them. A1 will be what? Minus 33. Okay. A2. Did I do the calculation correct? A2 is what? A2 is minus 2 over this minus 1. Okay. Let me double check the calculation. This is 27. This is 27. 3 minus 90. Yeah, this is not 75. This is the wrong. 27. 3 cubed. 27 minus 90 plus 6. That will be 33 minus 90, which is minus what? This is minus what? Minus 33 plus 90. 57. Yeah, so this is 57, not 75. So this is 57, sorry. This is 57. Okay. Now, A3 will be what? 3 factorial is 6, huh? So you have 6 equal 6 A3. So A3 equal 1. A4 will be 0. And the rest for n greater than or equal to 4. Now, what will be this summation then? It will be of an. That will be A0 plus A1 plus A2 plus A3 plus 0, because the rest is 0. So it is A0 minus 57 minus 33 minus 1 plus 1. So this is cancelled, and this gives me minus 90, and that would be the answer. That's a matter of calculation, nothing is complicated there. Okay, now this one, cosine 2x times e to the power x. We'll start with cosine x. That will be summation. 0 to infinity, minus 1 to the power n, x to the power 2n over 2n factorial. I need cosine 2x. That will be summation. N equals 0. What is ax? X summation x to the power n over n factorial. Now I need cosine 2x. That will be minus 1 to the power n. X to the power 4n. No, don't rush it. That will be 2x to the power 2n over 2n factorial, which is summation n equals 0 to infinity minus 1 to the power n 2 to the power 2n x to the power 2n over 2n factorial. Okay, now list them, try to get the, I think I need the coefficient until cube or x to the power 4. I think cube it will be, it will be cosine 2x. Yeah, let me list them. I have here what? 1 plus x, okay, plus x squared over 2 plus x cubed over 3 plus the other one is what? Now at n equals 0, I have 1, okay? At n equal 1, I have what? At n equals, yeah, that will be minus, at n equal 1. It will be 2 square, which is 4 x square over 2, which is 2x square. Yeah, it is 4x square over 2. Let me write it, 2x square. Now, what will be the next one? I don't think I need the next one, but it's okay. Let me write, because that will be x to the power 4. That will make it very big. Okay. With n, that will be the n2. I have 2 to the power 4, which is 16 x to the power 4 over 4 factorial. Minus the rest. Okay. So, what will be the coefficient of the constant? That will be 1. X, I have x. Only x times this. X squared will come through what? Through 1 times minus 2x squared. So what is the coefficient of x squared? I have 1 times minus 2 is minus 2, and I have x squared plus 1 plus half. That will be the x squared. Okay. Oh, I have it at the beginning. Okay. Plus what will be x cubed? What will bring me x cubed? 1 will not bring x cubed. X, it will be minus 2. X squared will not bring me x cubed. Yeah. X squared over 2 will not give me x cubed. But I have x cubed. So I have this is minus 1. Wait a minute. This is 3 factorial. Sorry. This is 2 factorial. Okay. Yeah. So this is minus 2 plus 1 over 6. Yeah, because this is times this. So it's plus 1 over 6. Plus the rest, which is x to the power 4 times the rest. I don't care. Okay. Plus the rest. That give me what? 1 plus x minus 3 over 2x squared. It's minus 12 over 6 minus 11 over 6 x cubed plus the rest. So this will be my answer. Okay, let me stop the recording. I think we did a good number. Yeah. Thank you.